A study by the state's Agricultural Commission plotted the number of avocado farms in each county against the county's population in thousands. The least squared regression line is this, where F is the number of avocado farms and P is the population in thousands. The residual plot is shown at right. Use the residual plot to determine if a linear model is appropriate. Why or why not? Well, I would say that these are not forming a pattern or a shape. So yes, a linear model is appropriate. Yes, a linear model is appropriate because the residual plot is not making a shape or pattern. What is the predicted number of avocado farms for the county with a population of 62,900 people? So we need to use the least squared regression line. So we're going to plug into F equals 9.37 plus 3.96 P, where P is a population in thousands. So for P, we would plug in 62.9. So we get F is the number of farms equals 9.37 plus 3.96 times 62.9. So 62.9 times 3.96 equals 9.37 plus 249.084 plus 9.37. So F equals 258.5 farms. Using the residual plot, estimate the actual number of avocado farms in a county with 62,900 people. So that would be 62,900 would be right here. So this residual is about, let's see if this is 10, 15, this is about 17. So it's 17 farms fewer. So the residual equals 17, and the residual is the actual minus the prediction, and the prediction is 258.5. Sorry, the residual is negative 17. So now we add 258.5, and we get that the actual number of farms equals 258.5 minus 17, which is 241.5. Ranger Sarah is responsible for monitoring the population of the elusive Gray's nightingale in Holly State Park. She would like to find the relationship between the male oak trees and the number of nightingales in the park. She randomly selects 7 different areas in the park and counts the trees and birds in each area. So Ranger Sarah got this equation. N represents the number of nightingales and M represents the number of oak trees. Her correlation coefficient was R equals 0.92 and R squared equals 0.84. So does this data exhibit a strong correlation? Explained using the correlation coefficient. Yes. Because R equals 0.92, there is a strong correlation. Because the highest it could be is 1, and 0.92 is really close to 1. What does the R squared value tell you about the data? So this R squared tells us that 84% of the number of nightingales, how do you spell nightingale? Nightingales is due to the amount of oak trees. The other 16% is due to something else. Factor each polynomial completely. All right, come on. All right, so I noticed that each of these has a 3 and an x squared. So I'm going to take out a 3x squared. So I get 3x squared times, here I'm left with x minus 1. On this one I can factor out a 2. So I get 2 times x squared minus 5x plus 6. Now I'll factor this with a box and a diamond. X squared and 6. 6x squared, negative 5x. So that would be negative 3x and negative 2x. X minus 3 minus 2. So we get 2 times x minus 3 times x minus 2 as our factored expression. For this one, I'm going to take out an 8. So I get 8 times x squared minus 4. Now I can factor that. X squared minus 4, negative 4x squared, and then 0x. And I know if things are going to add to 0, one has to be positive and one has to be negative. So it's positive 2x and negative 2x. X minus 2 plus 2. So we get 8 times x minus 2 times x plus 2. For this one, I notice I can take out a 2 and an x. So that'd be 2x. So I'm left here with 2x squared plus 5x minus 12. Now I factor that with a box and a diamond. 2x squared minus 12, so that'd be 24x squared negative, and then 5x. So I need two numbers that multiply to negative 24x squared and add to 5x. So that would be 8x and negative 3x. So I'll put a 2x here, and x. 2 times 4 gives me 8. X times negative 3 gives me negative 3x. 4 times negative 3 is 12, so we're good. So our final answer is 2x times 2x minus 3 times x plus 4. So here, the last homework problem for algebra. What was your favorite topic to learn about this year? Why did you like it? Was it easy or hard? And explain your answer in a few complete sentences.